Alright, let's continue. So, explain how the chemical bond is formed. Okay, so this is a very common question. So, this question is very common, especially in essay. Usually, the marks allocated would be probably 5 marks because if you manage to answer according to the sequence of points, which is very simple in reality, you could grab the opportunity to get those 5 marks. So however, here it is just 2 marks. That means you don't have to elaborate every single part of it, but if you happen to, if you believe that you know all those points, then go ahead and give your answers. Okay, so okay, explain how the chemical bond is formed. So for answering this question, we have to look back at what we have done before. So over here, it is, as I have told you before, it is there is a sharing of electrons happening over here. And when we are answering this question, there is certain parts you have to elaborate, which is what are the atoms involved. First of all, what are the atoms involved? And then you have to mention what type of bond is being formed here. In this case, there is 3 single covalent bond, and you also have to mention how many electrons that is needed for each of these atoms for it to achieve either stable duplet electron arrangement or stable octet electron arrangement. For hydrogen atom, requires one more electron for sharing, and for nitrogen it needs 3 more electrons for it to achieve stable octet electron arrangement. So you have to elaborate how many electrons is contributed by each of these atoms. So let's go ahead and answer. So explain how the chemical bond is formed. So you have to be very specific. Of the each of the 3 hydrogen atom contribute 1 electron for sharing. Alright. With the nitrogen atom. Alright. And then okay, let me see back the answer scheme. So the answer scheme has just given 3 points. Okay. One nitrogen atom has 1 pair of electrons with each of the 3 hydrogen atoms. So the 3 hydrogen atom contribute 1 electron for sharing with the nitrogen atom. 1 nitrogen atom share 1 pair of electron with the 1 nitrogen atom contributes 1 pair of contribute one electron for sharing with each of the three hydrogen atoms. Right, so I think there's a mistake over here. I'm supposed to, yeah, this part is supposed to be below here. This part until here. It's supposed to be elaboration next to this. It should be written here. I'm sorry, I think I don't wanna procrastinate any further by rewriting this. I'm just gonna say, okay, the first sentence should be one nitrogen atom shares one pair of electron with each of the three atoms. One hydrogen atom contribute one electron for sharing with each of the hydrogen atoms. Each of the three hydrogen atoms contribute one electron for sharing. So over here, if you look carefully, first of all, we are mentioning how many pairs of electrons are being shared between the nitrogen atom and the three hydrogen atom. So it is one pair of electron. Okay, it is one pair of electron. And then the next sentence mentions one nitrogen atom contributes one electron for sharing with each of the three hydrogen atom. So we are elaborating how many electrons are contributed by the one nitrogen atom. If you look back at the diagram, you could see that it's contributing one electron for sharing. So this X is the nitrogen's electron, and this black dots are the uh, electrons of the hydrogen atom. So the nitrogen X, there's one X over here, one X over here, and one X over here. That means it's contributing one electron for sharing with each of these three hydrogen atoms. So when you are mentioning this, it's extremely crucial for you to be very specific. You're telling each of the three hydrogen atom, and not just if you're gonna answer three hydrogen atom contribute one electron, it's definitely wrong. All right, because each of the hydrogen atoms are contributing one electron. You have to be specific. All right. Okay. Let's go back to the next question. I'll erase this real quick. Okay. Next. What is represented by the number 17 in diagram 3? So we are looking at three numbers in the standard representation of atom. So if you have already learned the periodic table of elements chapter 4 form 4 chemistry, you would know that this number is the nuclear number of any atom. Nucleon number. Let me spell it out for you so that you don't misspell it later. Okay, this should be the nucleon number. And how about the one at the bottom? So that will be the proton number, right? Proton number. Okay, so what is represented by the number 17? It should be proton number. All right. Okay, over here you don't confuse a lot. This number below represents the proton number. However, it also will automatically represent the number of electrons found in that atom. The proton number and the number of electron is the same for an atom. Let me emphasize, for an atom, not for, if it was an ion, then the proton number and number of electrons in the ion will not be same. However, for atom, since it has no charge, so the number of positive charges and number of negative charges will be equal, therefore it will be neutral. All right, what is represented by number 17? So as I've told you, it is proton number. Okay. State the period of element X. Okay, so whenever you come across a question that provides you with number of electron or proton number or nuclear number or whatever it is crucial for you to write the electron configuration straight away. So for 17, you know the first shell will be filled by only 2, the second shell will be 8, and the third shell will be 7. Okay, so if you sum up all of this, you'll get 17 back. This is the configuration of electron for each cell. Each shell, first shell will be 2, second shell 8, and the third shell is 7. The maximum capacity for the second shell and third shell is 8. It cannot exceed that, and if it is lower than 8, that means it hasn't achieved stable of that electron arrangement. Okay, so state the period. When you look at the electron configuration, you know that the number at the uh, at the back indicates the group of the element of the atom. So this is group 17. This is group 17, and the number of shells. Alright, the number of shells, I hope you could see my cursor. The number of shells are 1, 2, and 3. So the number of shells shows the period of the element. So over here, since it has 3 shells, the period will be 3. Let me period. Okay. Let me move it this way so that it will be visible for all of you. I'll just put it here. Okay. Write the chemical equation for the reaction occurs. Okay, X reacts with hot iron wool. X reacts with hot iron wool, produce brown solid. Okay, X is, it is from group 17. So group 17 is basically halogen. The other name is halogen, and I believe that if you're a very professional chemistry student, you're very good at chemistry. It's not exactly you have to be good. If you have learned chemistry for a certain while, you will be able to, I'm sorry for the sound pollution. So if you have learned chemistry for a certain while, you will be able to identify this without even looking at the periodic table of element at the back of your examination paper. Usually the periodic table of element will be provided at the back of your examination paper unless it is an informal exam. It's not an exam organized by the government, then maybe it's not SPM, then it's one of your standardized tests, then your teacher may not provide you with a periodic table of element, and it's crucial for you to have the knowledge to identify this. So this is a chlorine atom. This is a chlorine atom, right? Okay. This is, oh, I can't type it here, huh? It's okay. Okay, this is chlorine atom. So over here, when you're writing a chemical equation, you could either choose to let it be as an X, or you could write Cl. Alright, I'm sorry for the bad handwriting. Okay, where did my, okay. right, for the chemical equation. So hot iron wool, you know, iron is Fe. Okay, this is really bad handwriting. I need a proper surface if I wanna write this chemical equation. Now my mouse is malfunctioning. Okay, I hope everybody could write Fe properly, unlike me who's struggling to use this mouse. Fe plus x. Okay, Fe plus x produce Fe x. Okay, student, I would like you to think for a while. Is there anything wrong with this equation? I intentionally wrote it in an incorrect way so that you will be not fooled by this equation. So there is something considered a very bad mistake when you make it in chemistry. So as you can see here, I told you that this is chlorine. So chlorine is a gas in a room temperature, and usually whenever we are writing this chemical equation, we'll be referring to the real life situation. So when you are conducting this experiment, obviously since it exists as room temperature, it exists as gas at room temperature, so obviously it will be X2. All right, chlorine is a diatomic molecule. It only needs to it forms a covalent bond with another chlorine atom. One atom forms a covalent bond with another chlorine atom for it to form a molecule, a chlorine molecule, which is a diatomic molecule. So it is X2. And then another thing that you have to think back over here is the information given here. So if you're looking at this, maybe I'd like to emphasize this. All right, forms a brown solid. Okay, if you have learned your salt, your salt chapter, chapter 6 form 4, or maybe your chapter 1 form 5, about displacement of iron and blah blah blah, so you will know that this iron is a transition element. Even in the periodic table of element chapter, you would have learned that iron is a transition element. So when you are saying that it's a transition element, there are certain characteristics such as it has oxidizing number more than certain value, and then it also forms colored compound ions. Its ions are colored. So for Fe2 plus, I'm just gonna write here. So Fe2 plus. Okay, I think I cannot make uh, a superscript number here. I can't make it go up over here like it's supposed to be, but I hope you could understand. If it is Fe2, right, if it is Fe2, 2 ion, then it forms a green color solution, and it is dissolved in water. When Fe2 ion is present, it is green in color, green color solution. Right? For Fe3, Fe3 ion is brown color solution. This is a very important information for you to remember. There is color difference between these two, and it doesn't necessarily form a solution. It depends on the experiment. In this experiment, it forms a brown solid, meaning Fe3 ion is present. It definitely forms a brown color anything in any state, either solution or solid, and it's important for you to remember this fact. Alright, so over here it is Fe3, meaning that, okay, let's make a small F, okay, Fe, okay, Fe3 plus. Okay, the charge here is 3 plus. Let's take chlorine. Sorry for the bad handwriting again, I deeply apologize. Okay, for chlorine it will be negative. Alright, if you cross the charge, it will form FeCl three. Alright, I hope you get what I'm writing here. It forms FeCl3. Okay, so FeCl3. I'm back for you to pardon this bad handwriting. Anyway, oh, I forgot. I wrote it as X, so I can't write it as Cl now. Okay, X, FeX3. Well, if you're writing X, then you don't need this bracket here. You could just write FeX3. Alright. So balance the equation. Over here there is X, there is 2X. Over here there's 3. That means you have to put a 2 over here. Alright, 2 over here, a 3 over here, and a 2 over here. So now it is balanced. 2Fe plus 3x2 produce 2FeX3. So let me just check this real quick. Fe react with Cl. So yeah, I was correct, right? Okay, for the next question, calculate the mass of brown solid form when 0.3 mole reacts with hot iron wool. Okay, this type of question, this is stoichiometry, and it is one of the most easiest question there is in chemistry. So I think it's a shame if you couldn't master this part of questions, because it is very easy. All you need to do is you have to know the triangle. You have to know the triangle where the top part is mass, this part is mole, is mass, mole, and then this is molar mass, and same goes. There is three triangle. There's supposed to be three triangle, and again it will be same as before. The top part will be the quantity you're trying to measure. Either it's mass or volume or number of particles. This part over here, the left hand side, will usually be either number of mole or the Avogadro constant, if I'm not mistaken. Alright, Avogadro constant or mole. I think this part is supposed to be the Avogadro constant. Either way, The top part will be number of particles, and either side of this contains number of mole and the Avogadro constant. If it is mass, then this part will be number of mole, this will be molar mass. If it is volume, this part will be number of mole, and this will be molar volume. Okay, all of these molar mass and molar volume will be provided in the question. Okay, so for this question, okay, we know that 2Fe reacts with 3X2 produce 2FeX3. Okay, calculate mass of brown solid form when 0.3x reacts with hot iron wool. So in chemistry, it is extremely crucial. As I've told you, you have to be very specific with what you're trying to deliver. What is the answer you're trying to convey? So you just write back what you see from this equation first. You could see that 3 mole 3 mole x2, it's supposed to be a subscript, but I couldn't make it a subscript. Can I actually make it a subscript? I think no. I don't think so, but wait, can I? Oh, alright. Excellent. 3 mole x2, and you make a ratio, right? Okay, I forgot another part. We're supposed to make this longer. Okay. Okay, this stays here. Over here, you write mole ratio. You have to have this the header of your working mole ratio. Okay, you could simply put a dash or this dots. Okay, I think I moved it way too far. Okay, mole ratio. Alright, so you make your working as clear as this is. 3 mole x2 produce, they want the brown solid. The brown solid is FeX3. 2 mole FeX3. That's my 3. Okay, 3. Insert. Alright. So if it is given that 0.3 mole x. Okay, so if it is 0.3 mole, oh, capitalized, my man. Okay, x2 again, reduce. So this is the part you just do simple mathematics. So this is divided by 10, so this part is also divided by 10, so it's 0.2 mole. 0.2 mole Fe. Okay, I have to type this very carefully so that I don't give wrong information to you all. Okay, okay, that is mole ratio. So again, you have to have this header, so you write mass of FeX3. Okay. Okay, mass of it is number of mole multiplied by molar mass. So number of mole is 0.2. Don't have to show your units during your working. Oh, where do I find the multiplication symbol? I don't see any multiplication symbol. Can I use this? Okay, okay, let me just this representing the multiplication. Okay, hope that makes it clear for you. I repeat, this is the symbol I'm using for multiplication because I couldn't find the regular multiplication symbol. Okay, 0.2 mole. Okay, it's supposed to be 0.2 mole multiplied by, okay, how many we are dealing with? 56 Fe. You have to look back at this molecule. There is Fe. There's only one Fe. You ignore this number. When you're doing calculation, you temporarily ignore this number. At this part, you use the number in front, the coefficient. When calculating the mass, the volume, the number of particles, you refer to the number, the subscript number. So there is only one Fe. So Fe is this 156 plus with number of Cls plus with 335. 5. Okay, so basically this is how you will um, put it in your calculator. So you should get 56 plus 3 times 35.5 times 0.2, you should get 32.5 gram. Okay, over here you could put your symbols. If you insist on putting your symbols during your working, then make it clear. Make it clear for the examiner, for those who is going to um, uh, going to be examining your papers. Okay, okay, I still can't make this another hyperscript or whatever it is. Okay, let me try. How do I make this? Insert. Okay, it's not working. Okay, let it be. I'm trying to mean this is a hyperscript. It's the minus at the top of this mole. Okay, gram per mole. Okay, so when mole times with per mole, it will cancel out each other. You'll be remaining with gram. Okay, this is your physics ability, physics skills to handle with symbols and units. All right. Okay, that is all for that. What is the meaning of empirical formula? Okay, I did tell you I'm just gonna stop at question 3. Okay, I think this is where we ended. Alright, I hope that helps. We done 3 questions. I'll be covering the rest later on. Alright, so here's a quick review. We have understood, we have go through the meaning of isotope, the subatomic particle inside the nucleus, the particle that is negatively charged, and we even gave our explanation to this, why they have the same chemical properties, because they have the same number of valence electron. And over here we learned about 3 particles: ions, molecules, atom. Purpose of chemical bond formation is to achieve stable duplet or octet electron arrangement by donating, receiving, or sharing electron. Okay, over here you have to write every single one of this. Okay, the answer uh, the answer suggested in the answer scheme is only this. It's only this. Only this. I mean this. let me use is only this. This is the answer suggested in the answer scheme, and this is the additional information that you could give. These are the additional information. So when you're giving out additional information, you have to mention it all: by donating, receiving, or sharing electron. Okay. State the type of chemical bond in gas A. Usually gas is formed through covalent bond. I barely remember any gas having ionic bond. Okay, this is covalent bond. You could see sharing of electron happening over here. And fast forward, this is all that. Alright, I hope this session was very beneficial, very educative for all of you guys. So we'll see you again in the next video. So thank you so much. Goodbye. mm, okay, that should end the recording. Bye bye.